Welcome to the session on fractions, addition and subtraction. The objectives for this session are to understand the concept of a fraction, add and subtract fractions, and understand the definitions of improper fraction and mixed numbers and convert between the two. We will begin by taking a look at a visual illustration of a pizza analogy to illustrate the concept of a fraction.
Suppose we have a pizza divided into 5 parts. At the moment we have 0 pieces shaded, denoted here. And the total number of slices is denoted here at the bottom. Now we have 1, 2, 3, 4, and finally 5 out of 5 pieces.
We will look at what the numerator and denominator of a fraction are. If we have a fraction 3 out of 8, this fraction represents, for example, 3 pieces of a circular pie which is cut up into 8 pieces. The value on the top part of the fraction is known as the numerator, and the value on the bottom part of the fraction is known as the denominator. In this example, the numerator is 3 and the denominator is 8. Suppose now that we have 2 pies which are both cut up into pieces. One pie is cut into 2 equal pieces, and the other pie is cut into 4 equal pieces. It is not straightforward to add a piece in the pie on the left to a piece of a pie on the right, because the sizes of the pieces are different. So here this piece is 1 out of 2, and this piece is 1 out of 4. Then we can see that the piece on the left is equivalent to 2 pieces out of 4 pieces. And now we can easily add the pieces on the right to the pieces on the left. So 2 pieces out of 4 plus 1 piece out of 4 equals 3 pieces out of 4. Let's revisit the pizza analogy to illustrate the concept of addition of fractions.
If we have 1 over 4 plus 2 over 4, we can represent this in diagrams as a pizza split into 4 pieces with one area shaded representing 1 over 4 plus another pizza split into 4 with 2 areas shaded or 2 slices shaded as shown here to represent 2 over 4. And this equals, and again let's draw a pizza split into 4, and it represents 1 area shaded plus 2 plus 3. So that's 3 over 4. Now for another example. If we have 3 over 5 plus 1 over 5, then we can represent this as a pizza split into 5 pieces, as shown, with 3 areas or 3 slices shaded, as shown here, plus another pizza split into 5 pieces with 1 area shaded, representing 1 over 5. And this equals, and again, let's draw a pizza and divide it into 5 pieces or 5 slices. And so we have 1, 2, 3, and 4, representing 4 out of 5 pieces. Now for another example. 3 over 8 plus 2 over 8. Again, let's represent this in diagrams as a pizza split into 8 pieces. First, to find 3 over 8. And let's shade 3 pieces as shown here. Let's now draw another pizza, again split into 8 pieces or 8 slices, and then shade 2 of the slices as shown here. And therefore adding the two regions together gives us another pizza split into 8 pieces, and adding gives us 1, 2, 3, 4, 5 slices out of 8.
How would we solve 1 out of 2 plus 1 out of 4 without diagrams, or a half plus a quarter? First, convert the fractions so the denominators are the same. Here we only need to consider 1 out of 2, as this can easily be converted to have the same denominator as 1 out of 4. Multiply the numerator and denominator by the same number 2 to give 1 out of 2 equals 2 out of 4. Therefore, a half plus a quarter equals 2 out of 4 plus 1 out of 4, as shown. Finally, add the numerators to give 3 and leave the denominators alone to give 4. So we have 3 out of 4. Now let's add two slightly more complicated fractions. First, convert the fractions so the denominators are the same. Notice that the denominators are 2 and 3. We bring in here the concept of the least common multiple. The least common multiple of two whole numbers is the smallest positive integer that is divisible by both numbers. For smaller numbers, it is easier to find this, so it is easier to see that the lowest common multiple, or LCM, of 2 and 3 is 6. We will look at techniques for calculating the LCM of more complex cases in a later video. Now that we know the LCM for this example, we can convert the fractions so that they can be easily added. We're going to multiply the numerator and denominator of a half by the same number 3 to give a half equals 3 over 6. Similarly, we're going to multiply the numerator and denominator of 1 over 3 by the same number 2 to give 1 over 3 equals 2 over 6. Finally, add the numerators to give 3 plus 2 equals 5, and leave the denominators alone to give 6. Now let's add two different fractions. Again, convert the fractions so the denominators are the same. The denominators are 5 and 9, and the LCM, or lowest common multiple, of 5 and 9 is 45. So we multiply the numerator and denominator of 4 over 5 by 9. And we multiply the numerator and denominator by 1 over 9 by the same number 5 to give 1 over 9 equals 5 over 45. So we now have 36 over 45 plus 5 over 45. The denominators are the same, so we can now add. And so adding the numerators gives us 36 plus 5 equals 41. And we leave the denominators alone to give 45. Let's now take a look at some examples of fraction addition. Let's now revisit the pizza analogy again to illustrate the concept of subtraction of fractions.
Let's take a look at this example. 3 over 4 minus 2 over 4. Let's draw the diagrams or pizzas as before. We split the first pizza into 4 equal pieces and shade 3 of them, representing 3 over 4. Minus, now let's draw another pizza split into 4, and this time we shade 2 of the regions to represent 2 over 4, as shown here. So of course 3 pieces minus 2 pieces equals, and again we draw pizza split into 4 equal pieces, so we just have these 3 pieces here, and then we take away 2 of the pieces, as shown. So let's remove these, and we're left with 1 piece. So we have 1 over 4. Let's now take a look at another example. 4 over 5 minus 2 over 5. Let's represent this in terms of diagrams again. So let's split the first diagram into 5, or the first circle into 5, and shade 4 of the regions, as shown here. And the second fraction is again represented by another pizza split into 5, as shown here, with 2 of the regions shaded. So we are required to remove 2 of the regions from 4 of the regions. So let's represent this as a diagram. Split another pizza into 5 equal slices, shade 4 of them, as shown, and then remove 2 of the slices. So let's remove these 2 here, so that we're left with 2 slices out of 5. Now for another example. 7 over 8 minus 4 over 8. So again, let's draw another pizza, split it into 8 equal pieces or slices, and shade 7 of them, as shown. So we have 7 slices out of 8 shaded here, minus and then another pizza, split it into 8 equal pieces or slices, and shade 4 of the slices, as shown here. To give us another pizza, split into 8, and here we're required to do 7 minus 4 slices. So let's shade 7 slices first. As shown here, and then remove 4 of the slices. So 1, 2, 3, and 4. Let's remove these. And we're left with 3 out of 8 slices.
Now let's subtract these fractions from each other. First, convert the fractions so the denominators are the same as we did previously. The denominators are 2 and 3, and we know that the lowest common multiple, or LCM, of 2 and 3 is 6. So, multiply the numerator and denominator of 1/2 by the same number, 3, to give 1/2 equals 3/6. And similarly, multiply the numerator and denominator of 1/3, or 1/3, by the same number 2 to give 1/3 equals 2/6. Finally, subtract the numerators, 3 minus 2, to give 1, and leave the denominators alone to give 6. Now let's subtract two fractions from each other. As before, convert the fractions so the denominators are the same. The denominators are 11 and 22. The lowest common multiple, or LCM, of 11 and 22 is 22. So, we multiply the numerator and denominator of 7/11 by the same number 2 to give 7/11 equals 14/22. And we can leave the fraction 3/22 as it is, because the denominator is already 22. Now subtract the numerators to give 11. We have 14 minus 3 here, so that's of course 11. And we leave the denominators alone to give 22. Notice that the numerator and denominator have a common factor, 11. So divide both the numerator and denominator by 11 to give 1/2. The fraction is now in its simplest form. Let's now take a look at some more examples of fraction subtraction. We will now look at an example of a fraction in which the numerator is greater than the denominator. Let's take a look at 5/4. As you can see, this is 4 pieces out of 4 plus 1 piece out of 4. Since 4 pieces out of 4 is 1 whole, we have that 5/4 equals 1 and 1 out of 4. An improper fraction is a fraction whose numerator is greater than or equal to the denominator. So 5 out of 4 or 5/4 is an improper fraction. A mixed number is a number which consists of a whole number and a fraction. So, for example, 1¼ is a mixed number. You should be able to convert from an improper fraction to a mixed number and also convert a mixed number to an improper fraction. Let's take a look at another example. We are required to write 1¾ as an improper fraction. We can illustrate 1¾ as shown. We have 1 whole and 3 parts out of 4. As you can see, this can also be represented as 7 parts out of 4. And therefore, 1¾ is equal to 7 out of 4. Where clearly 1¾ is a mixed number and 7 out of 4 is an improper fraction. Now pause the slideshow and have a go at these exercises. The solutions will be released one at a time so you can check your answers as you go along. Pause the slideshow whenever you need to. Now have a go at these exercises. Pause the slideshow and have a go. Press play when you're ready to view the solutions. This brings us to the end of this session. To understand this topic in greater depth, do have a go at some extra exercises from your textbook related to this topic. Thank you very much for listening.